Hello, brilliant, thank you. So yes, my name is Dr. Carolyn Ashurst, and I'm a Turing Research Fellow at the Adrian Turing Institute, which is the UK's National Institute for Data Science and AI. And I'll be presenting joint work with Adrian on fairness without demographic data. So very much continuing a bit of a theme from this session, but perhaps taking a bit of a step back and thinking about this from a high level, and in particular giving a bit of an overview of some of the approaches that we propose to deal with this very common issue. Wonderful. So this community is, of course, very well aware of how easy it is for systems to be deployed that don't serve all communities well. For example, we've now seen many systems that don't perform well for certain demographic groups. So, of course, in response, the fairness research community and related subfields have done a lot of work to highlight such concerns and to propose methods to identify, measure, and mitigate such bias. So in particular, group fairness definitions and metrics have gained a lot of traction. And these metrics typically compare some statistics across different subpopulations. For example, developers of a system aiming to predict lung disease might compare error rates for different gender groups. So such definitions do have limitations and risks, but for now, let's assume that disaggregated statistics can be an important starting point for uncovering potential harms in some circumstances. Critically, though, to use such group definitions, developers or auditors need access to demographic data. So for our lung disease system, developers would need a set of data points corresponding to individuals with variables representing gender, whether they have lung disease, and whether the system predicted lung disease. But this access to individual level demographic information is a strong assumption. Recent work seeking to highlight the challenges around using fairness techniques in practice have highlighted a lack of demographic data as a very common challenge. So after interviewing practitioners working in fairness, Ashurst et al. States that almost every participant described access to demographic data as a significant barrier to implementing various fairness techniques. And there are, of course, a lot of reasons for this lack of data. So collecting demographic data incurs risks for individual data subjects and wider communities. So as described by Ashurst and Villeneuve, these include harms resulting from encroachments on privacy, such as discrimination, violence, chilling effects, and stereotype effects, harms from misrepresentation resulting from limited category options or inappropriate dimensions of identity, and harms from data misuse and use beyond consent. For example, if data is inappropriately repurposed, shared, or leaked. So in addition to these, organisational factors may prevent organisations from collecting demographic data. So these include restrictions or uncertainty around legality, company privacy policies, fear of alienating customers or negative PR, and cost, complexity, and competing priorities. So as a result, the lack of complete and accurate demographic data is very widespread. And this, of course, is no secret, and many methods have now been put forward to allow developers to do some form of fairness evaluation or mitigation, fair learning techniques, for example, despite these restrictions. So in our work to try and clarify this landscape, we wanted to understand the main types of available methods and start to think about some of their benefits and downsides. So in our work, we grouped the methods into 4 big categories. So firstly, collecting demographic data, which includes dealing with errors and missing values. Next, additional protections for collection, which includes the use of third parties and cryptographic solutions. Next, auxiliary data sets and inferring demographic data, which includes proxy methods, we've heard a bit about that already, that try to predict demographic categories from other data. And finally, alternatives to standard group approaches. So I'm now going to try and give a very quick feel for some of the techniques under each of these headings and hint at some of the key implications of each. So firstly, collecting demographic data. So for completeness of comparison in this category, we include the default approach that's often assumed by the fairness literature that individual demographic data can be collected and is complete and accurate. A strong assumption, as I said. We also include data linkage. So a real world example of this, the Sale Data Bank stores anonymized data about the population of Wales. And within their trusted research environment, an anonymized ethnicity spine has been created. And this can be linked to other health data sets that don't have race or ethnicity information. So, for example, this was used to understand disparities in COVID vaccine uptake, for example. And finally, errors and missing values. So while work to deal with missing values is, of course, not new, more recent work has tried to understand specifically how to estimate fairness metrics under such conditions. And while much prior work assumes values missing at random, for demographic data, of course, this is unlikely to be the case. And this has resulted in calls to understand the social dimension of so-called structured missingness. So next, we have additional protections for collections. So these methods assume that it is possible to collect demographic data as long as additional protections have been put in place. And these protections can often be used in combination with each other. So if it's inappropriate for the main organisation concerned to collect demographic data, but a trusted third party can be used to collect such data on their behalf, then different arrangements can be put in place to allow fairness evaluation. For example, the main party might supply additional data to the third party to perform fairness evaluation on their behalf, for example. Next, we have privacy preserving methods, which can be used to better protect the privacy of demographic data. So, for example, the demographic data could be encrypted by the third party, and multi-party computation, which we heard about earlier this morning, can be used to allow the main party and the third party to jointly run a fair training algorithm without the main party ever being able to access unencrypted demographic data. So these methods have many desirable properties, but they can incur large organisational and technical costs. And they can also present privacy fairness trade-offs and other active area research, particularly if we're thinking of things like differential privacy, which was briefly mentioned earlier. And finally, different mechanisms can be put in place to try and address specific hurdles to collection. For example, to address legal uncertainties or internal cultural obstacles, or to address the concerns of data subjects. Next, we have auxiliary data sets and inferring demographic data, which we've heard talking about already today. So proxies and attribute classifiers attempt to predict demographic categories from other available data. In some ways, these are perhaps one of the more controversial methods in our framework. So simple methods here include predicting race and ethnicity from surname and location. And this has been very widely used in practice. Other machine learning methods have also been used to predict attributes from a wide range of data. This, of course, raises questions about when predicting attributes is appropriate and meaningful, which is highly context-specific. Inferring demographic data can be used for very well-meaning purposes, such as fairness evaluation, but it has also been used in extremely problematic applications. In addition, one should be mindful that such methods can introduce new biases themselves, including when used for fairness evaluation. I think we'll have another talk in that direction in this session as well. So relatedly, since fairness mitigation strategies often rely on demographic data, Methods in fair learning without attributes seek to allow fairness mitigation, so things like training algorithms that satisfy the fairness threshold without access to such data. For example, to reduce bias in text-based occupation classification, researchers showed that penalising correlation between occupation and name word embeddings reduced race and gender biases. Relatedly, things like transfer learning can be used to train a system from a large amount of data from one domain before fine-tuning on a small amount of data. This can be used when group labels aren't available in the large data set. And finally, methods have been proposed to generate fair synthetic data that can be used to train fair models, or using synthetic data to create more balanced data sets. This can be challenging, and again, there can be privacy fairness trade-offs at play. And finally, we also consider alternatives to standard group fairness approaches. So although our main focus is on how to do group fairness evaluation with restricted data, we also discuss the fact that alternatives are available, which may not require demographic data. So this includes a wide range of technical methods. For example, some approaches guarantee a minimum level of performance for all subpopulations of a certain size, and thus don't need group labels specifically. There is, of course, also a wide range of more holistic approaches to fairness, such as qualitative investigations, transparency mechanisms, impact assessments, audits, and complaints procedures. Participatory methods and tools for responsible research and innovation seek to put societal needs at the forefront of the development process. So that includes our counter through the different methods. Hopefully it's clear that they each solve slightly different problems and they have different trade-offs. So which specific method is most appropriate for a given context depends on a lot of factors, such as data availability, the specific aim of the analysis, various environmental factors, such as the legal or cultural environment, and various trade-offs between the methods. These methods in general should be used with care and caution, particularly since many of them are in their infancy, and because some of them can introduce new biases of their own. So where does that leave us? So firstly, one is quite overwhelming how many different ideas are out there. In my opinion, it is a good thing that there are so many different lines of work. Firstly, because this is a critical problem to solve. Many developers and auditors are facing the challenge of lack of demographic data today. And because what we need is highly context specific. So we do need a range of solutions. So while we've provided a very high level take on these methods in our paper, further work is certainly needed to really understand the implications of different methods in specific contexts. So finally, to conclude, let me reiterate that this work is really needed because a key assumption underlying much fairness research, namely this assumption of complete and accurate demographic data, sits at odds with many real-world scenarios. So I'd like to end by highlighting the importance of work that tests such assumptions, such as these papers here, and for the need for fairness research to take such realities into account, so that over time we may close the gap between research and practice. Brilliant, and I'll leave it there, thank you.
Fantastic talk, thank you. Let's open it up now for questions from the audience. As usual, I will start with a question while others we get geared up. So right now we're talking a little bit about going into practice. Could you share a little bit of intuition about how you imagine that practitioners and regulators could utilize your research on fairness techniques? How might they find them valuable?
Yeah, so the hope is really that this is a starting point because it's such a common problem that people are facing. I think it is hard to know what options are out there and where to lead. So all we really try to do is just to provide a very high level overview so that people can at least be aware that there are these different methods out there, and in particular to sort of make the point that they are trying to solve, even though they are related by the scheme, they are trying to solve different problems, and they do have different assumptions. So, for example, things like using privacy preserving techniques have been put forward as a solution for dealing with the fact that there can be reluctance to give your demographic data away. And that's true, but you're sort of basing that on the assumption that people would be willing to give their demographic data if there was some encryption in place, for example. And that's a very particular assumption, right? It assumes that people, that's their particular concern. It assumes that they trust that those things have been implemented correctly. It assumes that that is the main barrier for them volunteering their data, for example, when in reality it could just be convenience, or it could be that they just don't trust the institution involved at all and won't trust what they say. So whether or not that is going to help you in that situation is very kind of dependent on those assumptions. So yeah, so we just hope that kind of by putting everything in one place, it makes it a little bit clear what the option space is, and when different types of solutions might be applicable.
Excellent, thank you. Do we have any other questions from the audience?